Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is inequalities. What we are going to discuss today is graphs of linear inequality. So let's begin. After completing the very lesson today, my dear student, will be able to draw the graph of a linear inequality. This is what I hope you'll be able to do after completing the very lesson today. So as usual, my dear student, your favorite segment of the lesson, that is Maths is Fun. Today, I'll give you another special number, another amazing number, another interesting number, and this number is 9. I will explain what is interesting about this number 9 after completing my lesson today, so don't go away. To begin the lesson, my dear student, let us learn the rule. It is this rule that will tell us what we needed to do in order to draw the graph of linear inequality successfully. So rule number 1 says draw the graph of the linear inequalities which separates the two regions. One of the region is called the region of the required solution, and the other region is now called the region of the unwanted solution. This will now be the two regions that you now have in your graph after drawing the inequality. While drawing this line, you take note of this. If your inequality is less than or equals to or greater or equals to, we call this included inequality. So use the solid line while drawing that very line. But if the inequality symbol was strictly less than or strictly greater, this we call it an included inequality. So in that case, you now use the broken line. So before you start drawing the line with your long ruler, you have to take note of this. You look at the back at your inequality symbol. If it is having O equals to, then use the solid line. If it were strictly less than or strictly greater, then you use the broken line. You now shade the unwanted region. The unwanted region is the region that didn't give us the solution. And that very region that gives the required solution, you have to label it R. You have to label it R, meaning you have to just write the capital letter R in that very segment of the graph that gives the solution, meaning the part that is not shaded. We are going to take examples step by step from the simpler one to the complex one, how we can now draw graph of this linear inequality. So let's just move. Example number 1, it says show the region defined by the inequality. That is the region satisfying the solution of this very inequality, x greater or equals to -2. So solution to this very problem, we always draw this inequality on a graph paper, not on a plain sheet. So you now have your graph paper like this, which you number it is x and y axis like this. So what this inequality says, x greater or equals to -2. So what you need to do to draw this very graph, you now locate this value -2 on your x-axis because the inequality says x greater or equals to -2. So find -2 on your x-axis. This is my -2 here, look at it. So what I'm going to do, I will now draw a line vertically to pass through this -2, and it will be parallel to the y-axis. So I'm going to locate -2, draw a line to cross this x-axis at -2. Look at the line in red. And I have used the solid line because the inequality is the O equals to. You can see it. Then this line, this red line, I don't know whether you can see it. Now divided my graph into right part and the left part, so I have to region C. So one of the region would now be region of the required solution, and the other region would now be region of the unwanted solution. So which region am I going to shade is the one that doesn't give solution. And this inequality says greater, greater. So values to the right, any point that you take, it is a value of x will now be bigger than -2. So which means this right of this line is the part that gives the solution, while the other part, if you take any point here by the left of this red line, the value of x will now be smaller than -2. And this doesn't give solution. So it is this that I'm going to shade. And how we shade, just use your ruler to draw lines like this. And you now mark this part as your R. That is the region that gives the solution. Let us move and take another example. Example number 2, it says to show the region defined by the inequality y less than 2x plus 1. Solution to this very problem. So looking at this inequality somehow a little bit advanced than the previous one, because I can see letter y, letter x here. So what I needed to do to draw this, I have to have a table of values. So let me have the table of values for this very one. So I just sample some few values on the left of 0 and the right of 0. Just the 3 is okay. -2, 0, and 1. You can decide to pick other values, but it's advisable to take the ones closer to the origin, that is 0. So let me find what will now be y when x is -2. So I'm going to substitute in this very y equals to 2x plus 1. So replacing x by -2 there, I'm going to have 2 times -2, which gives me -4. And -4 plus 1 gives me -3. So y will now be -3 when x is now -2. So to get y here when x is 0, I'm going to substitute the value of x by 0 in this. So you have 2 times 0, which will be 0 plus 1. So in the end, y will now be 1 when x is 0. So you continue. You now replace the x by 2 in here. So you have 2 times 2 plus 1. That gives you y as 5. So this is my table. It is this x and y values that I'm going to plot on this graph so that I will now join them. So starting with the very first one, when x is -2, y is -3. I will now locate x -2, y -3, where the two crosses, look at it, at this very point, x is -2, y is -3. So I'm going to make a small dot there, or a small cross, look at it in red. This is the point. X is -2, y is -3. So I'll move to the second point, x is 0, y is 1. X0, Y1. This is X0, Y1 at this very point. Look at it. So I'm now going to make a small dot there. Look at it. Look at it. This point is now X0, Y1. So I'll now mark the last point when X is 2, Y is 5. This is X to 2, and this is Y5. So it will now be here. So I'm going to make a small dot there too. Look at it. So it is this 3 set of points that I'm going to join to get my line. But before joining, you go back to your inequality and see it is either included or unincluded inequality. So this case is a solid line, so I'm going to use my long ruler to join this 3 set of points. They all fall on same straight line. If one deviate, which means either the value that you have in the table is wrong or your plotting is wrong. The 3 must fall on one straight line. Let me just draw that. This is my line drawn through this 3 set of points. So I have drawn my line. What remains is now to check which part will now give the solution of this inequality, which part will not give. So to do this is not as simple as the other one. What you now do, you have to have a test point. That test point is just to mark any point either by the left of it or by the right of it, and substitute the value of x and y at that very point in the inequality, whether you see it becomes a true or it becomes a contradiction. So let's just sample. If I sample this very point, x is 1, y is 2, I just take this right part of this line. If this is the required solution, then after substituting x1, y by 2 in this, it becomes a true inequality. But if it is the other way around, it's the part that doesn't give the required solution, it will give contradictory inequality. Let me just substitute x by 1, y by 2 in the inequality. So I'm going to have 2. I have replaced y by 2 less or equals to, replace this x by 1. So 2 times 1 plus 1. Let me just continue. So I'm going to have 2 less than or equals to 3. Look at it. 2 times 1 is 2 plus 1 gives you 3. So this gives a correct inequality or a true inequality, which means this part is the part that gives solution, whereas the other part doesn't. So it is the other part that I'm going to shade. So I'll now use my ruler to draw just lines like this, and I'll now mark this region capital R, meaning this is the region that gives the required solution. Let's just take one more example. Example number 3, it says label the portion or the region R that define this set of inequalities. You have 3 inequalities this time around. You have y less than minus 2x plus 5 is one inequality. And another inequality says x greater than minus 1. And the third inequality says y greater or equals to 1. So solution to this very problem, we always draw this inequality on a graph paper. This time around, I have 3 inequalities. Starting with the very first inequality, that is y less than minus 2x plus 5. To draw this on a graph paper, I need to have a small table of value because I have 2 variables, y and x. So let me have that table. I have my table like this with the samples values of x minus 1, 0, and 3. I keep repeating, you can take any, but advisably take closer to the origin, that is 0. So I now replace the x by minus 1 to find the corresponding y here. So replacing x by minus 1, I'm going to have minus 2 times minus 1, which gives me positive 2. And positive 2 plus 5 gives me 7, so I'm going to write 7 here. Replacing x by 0 in here, I'm going to have minus 2 times 0, which will be 0, plus 5, so corresponding y will be 5. Replacing x by 3, I'm going to have minus 2 times 3, which gives minus 6, and minus 6 plus 5, the answer will be minus 1. So this is my table. So what I'm going to do next is to bring out my graph paper, number it, and draw this line. So let this my graph. I have numbered it because I look at this small table. The values I have for y that are negative are just very few. That's why I bring my x-axis down. So let me just plot this set of points when x is minus 1, y is 7. X minus 1, this is x minus 1. Y7, this is y7. So this very point. So I'll now make a small mark there. Look at it. Look at it. So this is x minus 1, y7. I'll move to the next point, x0, y5. X0, y5 will be here. This very point, look at it, on the y-axis. So I'll make a small dot there. Look at it. Look at it. So next point is x3y minus 1. X3y minus 1. This is x3 and this is y minus 1. So it is this extreme bottom here. This very point. Look at it. So I'm going to make a mark there too. If your table is correct and your plotting is correct, these 3 points will now all fall on one straight line. So now go back to the inequality. The inequality, remember, says y less than. This is the inequality that we have. It is stable, and the one that we plotted, now we are trying to join. So I will go back to my inequality, see whether it is solid line that I'm going to draw or a broken line. The inequality is strictly less than, look at it, is strictly less than. So which means I'm going to draw a broken line. So my ruler, if I put it there to join these 3 points, I'm now making some gaps in between. So this is my broken line. So you now continue. So next is now to shade this region. One of the region gives you solution and the other region will not give you the solution. And how you do that for this kinds of line, you have to mark a test point. So my test point, let me just mark this very place. That is x is 2, y is 4. X is 2, y is 4. I'm going to substitute in this inequality and see whether it becomes a true one or a contradictory one. If it were contradictory, which means that the very part of this point will now be the part that doesn't contain the solution, it is the other part. So let me just substitute x by 2y with 4. So I'm going to have 4 less than. I have replaced y by 4, I replaced x by 2, so I have 4 less than minus 2 times 2 plus 5. Minus 2 times 2 gives you minus 4, and minus 4 plus 5 gives you 1 in the end. So 4 less than 1, you can see this is a contradiction. 4 cannot be less than 1. which means this part doesn't give out the solution of this inequality, which means it is this that I'm going to shade. So let me just shade it. So I'll now move to the other two inequalities. The other two inequalities are simple ones. I have x greater than minus 1, x greater than minus 1. This is the second inequality. So to draw it, I'll just move to the x-axis, locate the number minus 1. I'll now draw a line to crosses that x-axis, and the line will now be parallel to the y-axis. So while drawing, you can see the inequality is strictly greater, so which means it's a broken line. So let me just draw it. Look at the line, x greater than minus 1. So x greater than minus 1, it is this right part that gives the solution. This part doesn't give because values left here are smaller than minus 1. So I'm going to shade this. So I'll move to the last inequality, y greater or equals to 1. Y greater or equals to 1. So I'll move to my y-axis, locate the value this 1. I will now draw a line to pass through that y-axis at 1, and that line will now be parallel to the x-axis. And that line is now going to be a solid line because the inequality is O equals to. Let me do that. So I'm going to have this as my solid line to crosses the y-axis at 1, and I will now shade either top or bottom of it. And eventually I'll shade the bottom, but you can look at it. The bottom will now give values smaller than 1, and here I'm interested in those values bigger than 1. So which means it's the top that gives required solution. We always shade the part that doesn't give solution. So it is this bottom that I'm going to shade out. So you can see the triangle, and it is inside this triangle. Any point that you pick will now be the solution of the three inequalities. This is how we now draw graph of linear inequalities. With this, I have come to the end of this very lesson, my dear student. I hope you find it resourceful. And let me just move quickly to the last segment, which is fun, and I explain what is interested about the number 9. That is so special, so amazing in such that if you multiply 9 by any number, and if you add the digits in those results, you always get the 9 back. This is really interesting. That is 9 multiplied by any number. Those digits in the result, if you add them together, you surely get the number 9 back. Let me just sample some numbers. So let me take 9 multiplied by 2, this small number 2 multiplied by 9, the result is 18, I believe. If you add the 1 and 8, that's 1 and 8, the digits in the result. 1 plus 8, it gives you 9. Let me just take another number that I'll multiply 9. Let me take a large number, 125. So 9 times 125, if you do it correctly, you have 1125. If I add these digits in this result, let me see, 1 plus 1 plus 2 plus 5, sure it will give me 9. Let me take another number, 80. 9 multiplied by 80, this is the result, 720. If I add the 7, 2, and 0, it will give me 9 again. This is really amazing. Let me just take one more. So let me take 28. 9 times 28, the result will be 252. And if I add these digits in the result, that is 2 plus 5 plus 2, surely it will give me 9. This is really interesting. I'm so impressed with this very number 9. So multiplication of 9 by any number, the result, if you add those digits in the result, you get your 9 back. You can try as many as possible. Thank you for your attention. We see more of those things in mathematics in our subsequent lessons.